Alright, lesson 3. Fundamentals of electrical test equipment. Describe purpose, construction, operation, electrical test equipment. Give information, voltmeters, ammeters, ohmmeters, low voltage circuit testers, multimeters, simplified test equipment for internal combustion engine. Alright, your references are TM9 4910, 57112 and P, TM9 8000, applicable LLVC TM, and applicable multimeter TM. Alright, learning event 1. Describe principles of meters. Introduction. We do not know how to measure. If we didn't know how to measure, where would we be? Throughout each of the day, the various measurements, for example, the squeeze out of the right amount of toothpaste onto the toothbrush. When we go to the grocery store, we're paid according to the weight and size of the products we buy. We measure them time on the wristwatches and clocks. Another example, the daily measurement of the water with electricity supply through our homes. These measurements are made with the meters measure that how much you use the voltmeters and flow meters, water, electricity bills are based on these readings. You have probably seen at least one of these meters as electrical meters should be mounted on your house in plain view. These flow meters read by the meter man, and one way of many of the type measuring devices need to be show services personnel how the system is operating. Both water and electricity systems work best in certain pressure ranges. Both systems therefore include pressure measuring devices at various points along the line. Automotive electric systems also require various measurement indicate how they are operating. The automotive electric system resembles a water system in your home in many ways. Voltmeter. You know that the volt is measured by the voltmeter. You compare the flow of the voltage with the water system. However, you open the valve of the spigot of the water bathroom sink and the water flowed very slowly. Next time you open the valve, a few hours later, the water flowed back to normal. The problem was probably caused by the pressure loss in the water system. If you could have looked at the pressure gauge on the water system, you would have found that the pressure was lower than normal when the water flowed too slowly. So this tells you that the pressure of the water system affects the flow. This system is true with the automotive electrical system. When the pressure voltage drops, it causes the flow current to drop also. It makes also electrical currents and water working properly. For example, the electrical motors run too slowly. Solids, electromagnetics do not have enough strength to operate. Lights and lamps do not burn brightly. Let's compare with a simple electrical system, simple water system. See how the voltmeter measures. Notice the electrical system shown in Figure 20 containing the battery on the left and the battery is connected on the load on the right. Load can be then by an electrical component such as light bulb, electromagnetic, electrical motor. The current flows through the battery to load and through a load and back to the meter. Like the water system, the electrical pressure gauge voltmeter must sample the pressure of the voltage in the circuit. Figure 20 shows your voltmeter operation, electromagnetic, a pointer, and coils in the load to a battery. Figure 20 shows voltmeter operation. Caution. Always remove jewelry, wristwatches, rings before you can test any electrical equipment. These metals items can cause you to be shocked or burned. Voltmeter, which of the two connections connected with the electrical circuit, is following the manner. One connection is connected with the positive side of the circuit, the other is connected with the negative side of the circuit. These connections then become positive and negative sides of the voltmeter. By connecting the voltmeter in this manner, the equal voltage is applied with both in the voltmeter and load. The flowing of the electricity of the current now has two paths to follow. One path through the load, the other path through is the meter. The wires of the meters are very long and small in diameter, making a resistance high. This means very little current will flow through the meter. The resistant load varies depending on the type of the load, such as small lamp compared to a large motor. However, the resistant load is generally less than that of the meter. For this reason, most of the current of the circuit flows through the load. The two paths of the side-by-side of the parallel. We see that the voltmeter is connected parallel to the circuit. The voltmeter contains a point hand known as the indicating point. The pointer is connected to electromagnetic. The pointer electromagnetic are mounted with a pivot or a hinge pin. Can be moved and swung in like a door. A very small coil spring known as a hairspring holds the point zero when the zero meter is not in use. It also returns the pointer to zero when the pointer is in use. The voltage stops and the meter is disconnected. When the voltage is applied with the voltmeter, it moves into the current through the electromagnetic. The electromagnetic forces move the pointer away from zero. The amount of movement depends on how much voltage is applied. The voltage increases, and the current will increase. So, as the voltage decreases, so does the current. The measure more pressure of the voltage applied with the circuit, the more current the flow will. The voltmeter will therefore change the voltage changes. And when it changes, the voltage changes. changes. Main thing to remember: the voltmeter is connected parallel to the main circuit. If in the voltmeter connected the current with the circuit passed through the meter, it would be connected series. A voltmeter accidentally connected with in this manner, it would most likely cause the indicating the source of voltage. However, the load components would not operate normally due to the high resistance of the voltmeter placed in the circuit. When the voltmeter is used to test a battery or no load of the positive to connect to the positive, negative is connected to the negative. However, there's in this case the meter and the battery make up the complete circuit. Voltmeters do not look alike. They have many types of size, with the portable voltmeters, large complex electrical equipment. The built-in voltmeters, because of the slight variation in voltage, greatly affect operation of this equipment. Operators or service personnel must constantly measure the voltage of such equipment and make adjustments whenever needed. Automotive electrical systems are not sensitive in design and more variation in voltage. Therefore, built-in voltmeters are not needed on vehicles. If voltage varies more than allowed, the voltage through is thought to be wrong. Portable voltmeters are available to measure for this voltage. Some voltages are separate cases, while others with the combination type of the meter with the two gated. Example, the combination meters are low voltage circuit and multimeter. The voltmeters are depending on these models used. For example, the voltmeters have only one scale, the other have two or more scales. Portable voltmeters include flexible test leads, lengths of wire, male plug of the meter, and the test probe with the alligator clip on the other end. The test leads are usually a colored red or black. Red lead is connected with the positive terminal with the meter, and the positive lead is of the circuit to be tested. The black lead is used to connect the negative terminal to the meter of the negative side of the circuit. There are two ways we can connect the two test leads to the meter so that all the ranges can be used in one method. The test leads always connect with the same two terminal sockets of the meter. Selector switch is used to select the proper range. Second method uses one common terminal over the negative and positive lead. Other lead is connected with a different terminal over each of the range. Why do you need more than one voltmeter? You may not have a range between 0 and 500 volts, so that is not practical. Electrical test meters must accurately center the scale or range. This means 0 to 500 volts would be most accurate around 250 volts. Volt battery generator voltage on most vehicles is 24 to 28 volts. You therefore be using a voltmeter testing the range from 5 volts to a fraction of 1 volt. Suppose you were issued a voltmeter like one in figure 21. Do you think you would use it? Notice that the new meter dial connections, range and scales and selectors in it, which indicate that there are actually 4 range of voltmeters: 0 to 1, 0 to 10, 0 to 20, and 0 to 50. A range 0 to 10 can accurately be used in selector switches of 0 to 1 volt position. Number 0 to 10 scales then become tenths of a volt. For example, 2 because it becomes 0.2 tenths of a volt, 3 tenths of a volt, and 10 volts becomes 1 volt. Figure 20 shows your measuring device voltage. Vehicle frame, negative lead in black, red, and bottom scale 24 volts set on the DC volt to 100. Let's assume you want to test the voltage in circuit figure 21, which includes a set of batteries. Make sure that the selector switch is off. The connector for the test lead of the meter is on the figure. The red lead connects the positive terminal. Black lead to the negative terminal. Next connects the lead with the circuit to be tested. Remember the parallel across the circuit that connects the red lead with the parallel positive side. Black lead to the negative side. Now that you are ready to measure the voltage to turn the selector switch to 100, you have connected the meter to the circuit. If the battery charge and load in the circuit is small, such as a small light bulb, the meter should be indicate close to 24 volts. Notice that above the center of the scale, you see the checking of the defect of the 24 volt circuit with a heavy load. If the switcher selects 50, the meter indicates approximately about 12 volts. If you want to get more exact measurements with switch selector to 20, you're now using 0 to 20 scale. It's easier to read the particular voltage. Caution, you must turn the switch selector switch back to 50 or off before it's heavy loaded with the disconnected from the circuit. If you do not, the meter will be damaged from the voltmeter past 20 volts when loaded is disconnected. Notice the range of the selector switch. With the highest range from 0 to 50, the selector switch is turned to the right with the range becomes smaller. Prevents burning out of the meter operating and having to go through high ranges first, and then once the operator leaves the off. Let's review what you've learned first. We learned automotive electrical systems, and in many ways are similar to water systems. Learned electrical pressure measured, voltmeter, water pressure measured with the pressure gauge. You also may learn with a voltmeter connected with the electrical circuit. You may also have one of the many of the measures that can be made upon automotive electrical systems. Let us now see how the current can be measured in an ammeter. Ammeters. If you want to find out how much water is flowing through the pipe in the water system, we install the flow meter for the basin in the pipe in such a way that all the water moving through the pipe goes through the meter. The meter counts the measure for the gallons of water that move through it. The ammeter does the same thing in an electrical circuit. The ammeter measures the amount of current moving through the wire. With the flow meter measure the water flow in the gallons, and the ammeter measure for the electrical currents in ampere. The gallon unit measurement of water, other liquids, ampere, and unit measures electrical current. Amperes are often called amps or amps of current. Figure 22 shows a battery, magnet, and a magnetic coil and a needle. The ammeter is placed in the electrical circuit in a way that all the current flows through. But necessary to break the circuit is necessary to break the circuit. Connect the ammeter to it. The electrical term for the type of the connection is series. The series circuit is only one path of the wire with which the current can flow. An ammeter is always connected in series, and so it can be measured a total amount of the current amperage flowing. Figure 22 shows the right way to install an ammeter. Okay, so it goes from ground to ground, ground battery to the ground. Alright, the three general types of the ammeter. The first type of the instrument with the pan, with the automobile, with the truck, particularly with the ammeter identified with the zero center of the scale with the equal numbers each side of the zero. A minus negative symbol will discharge located with the far left of the numbers from the positive signal, with the charge is located in the far right number of the numbers. The ammeter shows the operator when the battery is charging and discharging. The second type of the ammeter has a zero located with the left side of the dial. The numbers increase with the right side of the dial. The ammeter is found with many battery chargers. Its purpose is to show the rate of the battery is being charged. Third type of the ammeter is found with the automotive testing equipment that can be identified with the zero located with the close to the left side of the end of the scale. The numbers increase with each side of the zero. Right side increase with much more than the left. Let's find out how this ammeter is used. Ammeter resembles a voltmeter in many ways. It may contain one or more scales in phase with the dial. With the ammeter with only one scale, like voltmeters, are limited use. Ammeters with the two or more scales generally have the terminal connection on each scale, but instead of the selector switch, especially with the ammeters made with measure high amperage. Amperage meters have terminal connections for each change with a common terminal. One test lead with a connect with the terminal, and other is connect with the terminal in range desired. The ammeter, like the voltmeter, may be with a separate meter with a part of the test instrument that contains other test equipment. Electrical portion of an ammeter must be connected with the handle with the amperage it must have. An internal shunt of the resistor is built within many of the ammeters to carry the current. Such ammeters are used to test very high voltage. These measures are made with the connect with the external shunt and or resistor to make the test. As for this purpose of the exterior shunt terminals on the main many meters of electrical lead with the connect with these terminals external shunt assembly to include meter circuit. All meters leads with the connect with the meter with the right polarity, red to positive, black to negative. As you know, with the now circuit must be broken. The ammeter must be connected in series so that all the current will pass through the ammeter and external circuit. Ammeter is easy to use with follow the proper procedure. Should never connect with the ammeter with the circuit under load will cause the arcing of the test lead with the connect with it should injure you as well with damage of the equipment. This is especially true with the circuits that carry with the heavy amperage load and the load of the can be generally disconnected with the opening switch. Ammeter should never be connected while the vehicle engine is running. Make sure all switches have been turned off, including the master battery switch. You should always determine the amount of the amperage current that they are going through the measure for the information that can be found in the vehicle technical manual. If you are not able to find out the amperage circuit that does carry with the start with the highest range of the ammeter of the work down through this method, you will not damage the ammeter. You have the range of the scale of the handle. The amperage, in fact, always be best to start testing on a scale higher than you think is necessary with a particular circuit. Let's follow the hookup with the ammeter with the circuit with a fully charged 12 battery load with the switch with the connect with the disconnect with the load with the battery loaded with a large lamp that's similar to the headlamps of the vehicle with the information included with the circuit to indicate the should be about 10 amperes flowing for the switch is closed. The ammeter have the ranging from 0 to 10 amperes. However, will you use of 0 to 50 amperes, which just in case a flow happens to be more than 10 amperes, which could harm the meter in the 10 ampere range. The meter connect with the red with the positive lead with the common terminal with the meter with the marked positive, and the black negative is connected with the 50 ampere terminal on the meter. When you know the ammeter is connected with the interior with the circuit that we have also connected with the red lead with the positive side with the circuit, the black lead with the negative side with the circuit, and generator output rate with the current flow through that was generated back to the battery with the red scale with the leads with the connected with the circuit, the reverse and load. So tested with this would also be red positive, lead negative. lead to negative and black, negative lead to positive. Any load of the circuit would be indicated with the left to 0. With the downscale, charge with the rate of the generator would be indicated upscale. Once you have connected it correctly with the load test that's complete with the circuit with the closing of the switch, of the current will then flow over the battery through the lead, load through the ammeter to the switch, and back to the battery as the current passes through the ammeter. Amount of the current flow will be indicated with the upscale of the side of the ammeter. Your amperage capacity of the ammeter depends on the construction ammeter used in the load of the test above can accept no more than 100 amperes through the meter with an external shunt with a greater amount of the current can be used. You will learn how the shunt is used later. From what you can cover, you foresee the automotive electrical circuit or system can be compared with the water system. Both systems work under pressure. The pressure can be measured. We also learn the pressure can flow in the system. When the system is used, the flow can be also measured. The amount of the flow in each system depends on the amount of pressure and how much resistance the circuit is system. In the water system, the size of the pipe and the valves can create the resistance in the system, and the water change of the pressure and increase the resistance as decrease the flow of electricity in a circuit depends on several factors. One of the important is the resistance. How can we know the resistance of the correct is in a circuit that's correct? One way to measure the voltage and the ampere meter. The voltage is correct and the amperage is not. You can safely assume that the resistance is wrong. You may measure the resistance if the measuring will use. We can measure resistance by itself using an ohmmeter. Or your ohmmeters. Anything that moves the meter resisting the opposition to the movement. Remember what happens with the space capsule when it returns to trip in space. It gets hot and have to have a heat shield to keep the astronaut from being burned to death. The heat is caused by the resistance air of the space capsule move through it, and the faster the capsule moves, the greater the resistance of the air, and resistance of motion always creates heat. The resistance, opposition to movement of the electricity when the wire produces the heat that sometimes we want with the loss of the resistance in the wire. For example, the wires in the burner of the electrical stove get red hot, and wires in the light bulb get hot to shine and produce light. At other times, we want little resistance as powerful electrical circuit because the resistance does that cause heat, loss of voltage, and reduce the amount of the current can flow. Unit measure for the electrical resistance is ohm. The instrument is used for the measure of the resistance electrical circuit in the ohm meter. Alright, many things happen with the electrical circuit will change the amount of the resistance of the circuit, the rest of the corrosion of the wires joined together will increase the resistance. If the wires are not tightly joined together, they will increase the resistance. If the wires have been partially with another cause of the high resistance. Whenever the cause of the resistance in the circuit is too high, but the load of the unit in the circuit, this is horn, radio, headlight, and starter will not work right to work at all, work at all. Meter may be separate meter, but often is part of the combination type meter, also known as a multimeter. The combination meters are sometimes called volt amp meters. These amp meters are construction depending on the manufacturer. Let's find out how the simple ohm meter looks like and how it is used. Figure 23 shows the ohm meters. Most simple ohm meters have one scale, but the scale is calibrated with the number 0 to infinity. The symbol of the infinity looks like a figure 8 and laying on its side. Infinity means more than the meter will measure. You should notice the figure 23, the dial scale goes from 0 to 50 and then to 1M, 2M, and then infinity. 1M means 1,000 ohms, 2M means 2,000 ohms. An ohmmeter is an ammeter, the measure of the current flow with the thousands of the ampere, with the type of the ammeter referred to as a milliamp meter. The most ohmmeters consist of the milliamp meter with the meter, some of the current limiting resistance unit. In this case, the most ohmmeter with the resistant unit, actually two resistor, the fixed resistor, and the other is a variable resistor. The simple ohmmeter has two test leads connected with two terminals. Ohmmeter has many U with the measure resistance located with the short and open circuit with the check of the circuit. Continuity 0 resistance. For example, the consider the wire with the broken somewhere with the inside of the wiring harness. You can see with the ends of the wire with which they connect to the circuit, but the rest of the wire is hidden inside of the harness. The ohmmeter can check for the continuity of the wire and prove that it is not broken. Prove if it is broken. Using the following procedure when going in the test ohmmeter, remove the ohmmeter test lead from the case connected with the two terminals of the ohmmeter. If the wire is tested with the vehicle, turn off the electricity of the vehicle electrical system. This is important. The ohmmeter has its lowest voltage battery of the meter will burn out when the high voltage enters it. Next step is 0 ohmmeter of the meter is not in use. The pointer with the hand will be back to the infinity mark with the 0 of the meter of the touch that leads everything together and complete the circle. The meter hand does not move the 0 from the 0 to ohm adjustable knob. It does. It changes the resistance variable resistor. You will find that meter ages you have the adjusted 0 ohm adjusting knob more to make up the weaker battery. With the hand will not come back to the 0 with any adjusting. The battery is too weak and must be replaced. When the ammeter is zeroed, connect one lead at each end of the wire being tested. The wire is not broken. The test of the wire is complete with the circuit of the ammeter. Hand will be moved to zero. The wire is broken with the circuit will not be completed. The hand will not move. The ammeter is valuable for test switching. So suppose you have a small on and off switch. If you think of it as not working, even though the lever switch is clicking normally, the switch has two electrical terminals. To test the switch of the ammeter, zero ammeter. Explained with above. They connect one test lead to each terminal of the switch. The switch on the off position of the ammeter should move. The move of the switch of the on position of the ammeter should move to the zero. Ammeter remain with the zero position on and off. What would this tell you? Remember that makes that hand move to zero of the complete circuit of the ammeter of the switch. This tells you the switch is not working properly. It does not break open on the circuit, and on the other hand, the ammeter indicating infinity on both on and off. The circuit is not being closed, and this means the switch is making contact inside. You now see the ammeter can be used to locate open circuit, the defective switches, and broken wire. You can also use the ammeter to check these for sure. So I'm on a grounding effect. But let's go over the back of the simple on and off switch. Check with the see if it's ground. You know that the vehicle, the chassis, of the one wire of the part of the circuit. If the switch is mounted on metal, the circuit through the switch must be insulated with the metal. The circuit will be grounded out. If the insulation fails due to the cracks or breaks or wear set forth due to the contact of the terminals touch the metal frame and the ground out. Test the switch with the grounding connecting one ammeter test lead to the metal frame and the switch with one to the terminal. Ammeter should not move. Switch is not grounded. The change of the switch position will look at the meter. Test the roll for the terminals in this manner. If the ammeter hand moves to infinity, the switch is grounded. If you have a complete circuit to continue with the terminal through the switch metal frame, the switch must be replaced. So far, we have tested the use of infinity and zero. How about the numbers between the two? The numbers that you want to use to measure resistance. As a wheeled vehicle repairer, you will not have to remove the replace the many resistors. However, you would be able to work with the many electrical components. Many of the components function with the property do not play for the. You do play for resistance of the electrical circuit. Earlier in the lessons learned with the component of the call the load in the circuit. If the resistance of the components is not have the specified resistance of the component of the electrical circuit will not function properly. Let's see how the ammeter used to measure the resistance of the load. And let's assume that we have the circuit used to fuse protected. Some circuits of the circuit breaker protected with on-circuits include with a set of batteries, electromagnetic on-off switch 3 amp fuse for the purpose of this test. Let's say that the circuit below for each time of the replacement fuse is installed and switch is closed. Circuit has checked the wires is not grounded with the fuse if the right amperage for 3 amperage for the circuit of the battery voltage is 24. The fuse will not last long enough to make the amperage load for the test on the circuit. The only component on the circuit that creates measurable resistance of the load, electromagnetic. According to the wire schematic, electromagnetic should be placed at 12 ohms of the resistance of the circuit, which will disconnect the electromagnetic circuit to measure the electrical resistance. Do not forget zero on the ammeter first. Remember that the circuit should be tested and hooked up in the series of the ammeter. For the purpose of this test, let's say the ammeter held hand indicates 6 ohms on the resistance. This only half of the 12 ohms if the electromagnetic should have. Could this differ because of the 3 amp fuse to blow? Cause the 3 amp blow to fuse? Remember the law learned in the so far electricity, the one that states that resistance increase of the circuit, the voltage remains the same and the current and the amperage decreases. In this case, we have the opposite of the law of the resistance increase of the voltage remains the same. Therefore, the amperage increase to more than 3 amperes, the fuse blows, opens the circuit that protects the circuit from overloading and otherwise to damage the wiring components. You know now how the ammeter can help you test circuit and switch and locating electrical system problems. Ammeter will probably will be part of the multimeter, which is covered later in this session. Remember, the ammeter is actually an ammeter always connected in series circuit. They always disconnect this vehicle battery and batteries from circuit before connecting the ammeter to the circuit. You will use the ammeter to measure resistance, look up open circuits, broken wires, short and touching wires. You can also check for the operation of switches located in the ground and circuit. The ammeter is a valuable meter. Take care of it. So far, you've learned the voltmeter, ammeter to separate test meters and instruments. If it's more practical to combine these meters into one unit. You will have using 2 combined instruments, a low voltage circuit and a multimeter. Alright, learning event 2. Describe the construction used of the low voltage circuit tester. The military low voltage circuit tester is a heavy duty testing instrument with open in the case of the 2 test meters. They're already familiar with the ammeter voltmeter, but they are in connection with the control of the valve and the ammeter and voltmeter. Some repairers shy away from the low voltage circuit tester of the relay simply to use only open once you've learned each of the connection control of the low voltage circuit tester. It will make the troubleshooting problems a lot easier to solve. The construction. When you're assigned a unit with the authorized low voltage circuit tester, learn how to use it as soon as possible. If you have the unit with a second low voltage circuit tester that doesn't look at anything like first, do not send it back. For Army now serves the different models of the low voltage circuit tester with only the federal stock number, and this means that a unit may order a low voltage circuit tester under the FSN 49100929136. Receive one of several different testers. All low voltage circuit testers indicate 1 ammeter, 1 voltmeter. However, the controls and connections vary. Low voltage circuit tester in your unit can be made with the following firm: the auto test in model automatic engineer, and it goes through several more. If you tried to learn each of the low voltage circuit tester from one lesson, you would be very confused. However, if you know how to use one, you can easily learn how to use the following instruction. Let's see what the Alien Model 3092 low voltage circuit tester looks like and how it is used. Alien Model 3092 low voltage circuit tester is a portable hand carry testing instrument used for the testing of low voltage DC electrical circuits on automobile vehicles. It includes the voltmeter, ammeter with the measuring voltage, ammeters, load bank, and adjustable resistor units. Load bank is used for the current tests of values up to 100 amperes on a 20 volt circuit, 4 volt circuit. Component and location and purpose. Illustration: the low voltage circuit tester. An illustration of the low voltage circuit tester, the covered and removed from the various control of the meter with the connection with the face of the instrument. Start with the ammeter located with the upper left side of the tester with the range from 0 to 500 amperes to the right of the 0 to 150 amperes from left to the 0. The ranging of the scale known as the minus 150 amperes plus 500 amperes range. Minus figures are always used to measure reverse current without reversing the meter's leads. The course load located directly below the ammeter is part of the load bank with control. The control has 8 positions on and an off position. During 20 volt 4 volt load operation, each position is at 12.5 amperes of load with the knob during the right to the turn to the right. If the tester is being used at 12 volt load operation, at each position at 2 8 adds 6.5 amperes of load. Position 1 of course load control, no current control during the 12 load operation of load bank. Also has fine loaded control located right of the course load control. This should use one of the amperage of load between the 12.5 ampere position 24 volt. They also can be used with the 12 volt load operation. The field result rheostat control located in the lower right of the tester variable resistor. If you use the string with the generator output, the control should be to the left of the open position with the field resistor rheostat is not being used. The voltage upright with the tester with the 2 scale with the 4 rows of the member of the 4 ranges that can be measured from 0 to 50 volts. 0 to 10 scale is used with the accurate 0 to 1 volt scale range. The voltmeter had the range of selector or switch located on the lower left. The switch of the left of the voltmeter dial indicates the turn of load bank on and off and should be left on the off position when not in use. The compartment over the right hand side of the tester is used with the store test leads. These are 7 separate leads with external shunt, with the leads consist of 4 16 gauge light and leads 3 black and 1 red. 2 6 gauge heavy load, 1 black, 1 red, 1 black jumper lead, and 16 gauge leads used to connect the voltmeter circuit with the connect with the rheostat with the generating circuit. The 6G gauge leads are used to connect with the adjustable load bank ammeter and fixed resistor to the circuit. The black jumper lead can be used easily anywhere with any of the circuit with a low ampere. The external shunt consists of 2 large and 2 small leads if used when measuring loads of negative 150 amperes to positive 500 amperes. They are above the ammeter, voltmeter, long, short, and cut end in metal. These slots allow air to circulate through the low voltage circuit. Testing for cooling. They're very important when the meter is in use and that they are not covered in any way. Many terminals connection located under the 3 front side of the low voltage current tester. We'll start with the terminal to the left of the ammeter. The first terminal is used for the connection external of the low voltage circuit tester. For the terminals with the polarity and positive and negative, the small red lead shown for the negative and positive, then terminal with the black lead and negative terminal. At the top of the terminal is head screw with the kernel. Rough does not slip in the fingers and the screw with the thing with the long and smooth nut. And the nut is a hole of the board of the right angle through threaded screw hole of the test leads a long hole with the meter end with the fits into the lobe and the hole. To make a connection with the loosening of the curled screw head by hand, you unscrew the kernel screw until the test lead pin slides in through the hole. Turn the kernel screw into it snug on the pin all the way, tighten hand only. All test lead connections are connected in this manner. Just below the external shunt connections, you will see two straps. Each strap that's connected with the two terminals of the straps are called links because they are linking of the circuit they are connected. When say they actually switch because they can be used with the open and close of the circuit. Upper link is used with the external shunt. The next four terminals are used with an ammeter. 6-gauge test leads are connected to these terminals. The terminals are marked with a negative for a negative symbol. Or a minus symbol. Each of these three marks over the one of the scale range of the ammeter. The fourth terminal is of the common, is therefore the positive connection of the three ranges. For example, if you wish to measure a current ranging from 20 to 30 amperes, you connect the leads to the low voltage current tester as follows. The red lead positive to the common terminal, and the black lead to the negative 50 amp terminal, and the other ends of the leads would be connected in a series of circuits to be tested. The two terminals located below the fine load marked at 24 volts, 12 volt respectively. The terms are used with the common terminal placing the load on the circuit with the load bank. 6-gauge tester is also used with these terminals because heavy amperage up to 100 amps of 24 volt circuit can be forced to flow through these terminals. The black lead is connected with the common terminal when using the load bank. The red lead is connected to 12 to 24 volt terminal depending on the voltage circuit being tested. The next two terminals are used to connect the fixed resistor of the circuit. The resistor located in low voltage contact circuit tester is rated at 0.25 of an ohm of resistance used to test some of the voltage regulators. The next two terminals are marked as field rheostat. The terminals are used to connect the adjustable rheostat to the circuit. The field rheostat is used to change the strength of the electromagnetic generator, changing the generator to output. It also can be used as a varied amount of resistance and other electrical circuits as desired. Last two connection terminals are made with marked with a voltmeter. One terminal is made marked positive, the other is marked negative. The terminals connection and voltmeter are located on the right side beside it. 16-gauge color coded test leads, red and black, are used with these voltmeter terminals. Voltage range between the two terminals connected with the terminals in proper range of the voltmeter off and on switch between the 2 meters and you the turn and load bank on and off. It is always left on the off position except when the load bank is in use. As you can see, the low voltage current circuit tester for simple test during the lesson. In this lesson, we discuss only one type of low voltage circuit tester to help you learn what tester it is and what it is used for. Each low voltage circuit tester has an instruction book. If you have any questions how to use the tester, always refer to the instruction book. Alright, learning event 3. Describe construction of multimeters. Introduction. You know the ammeters that you will use the part of multimeter. The low voltage circuit tester had more than one meter, but the multimeter, it measures the only DC voltage amperage, and therefore it's called the low voltage circuit tester. The multimeter measures AC and DC voltage amperage and resistance. Construction. Figure 25 first difference of the notice with the multimeter with the low voltage circuit tester. If the multimeter has only one dial, the dial has a scale indicate the values each of the tests of the meter only can make. Figure 25 multimeter. There are several kinds of multimeter made with a different manufacturer, generally most of them same controls. The jacks of the various tests are usually located around the edge of the meter with the thereby common jack with the U with the negative lead with all the test with the positive lead and plate for the appropriate jack with the test being made with the sum of the multimeter, the range of the selectors switch with the U instead of the separate jack for each of the range of these meters have common positive and negative jacks. The rheostat enabled U with the zero adjusting the meter to zero resistant test. The switch knob of the position component of the meter in the proper circuit test to be made. The meter dial usually has 3 scales. One scale with a DC measurement that can be either voltage or current. Another scale with the ohm scale. Remember, the scale is reading right to left in order. In other words, no resistance circle at that point will go all the way to the right or to the 0 ohm. The resistance increase the pointer will stay far to the left. Another scale with the AC voltage. You remember, with the all meter scales will not be the same. They must also each meter in according to the way they were designed. As gaining experience in the automotive electrical system repair, you will learn approximately resistance each component. For example, you will learn the circuit can connect with light wires, 18 gauge or small, with the current flow with it going to be low, dividing approximate current with the flow of the amperage of the volt. You will come get some idea what the resistance should be. Always check with the specification of the system component with the exact amount. You should be able to find either the current resistance for the most component of the technical manual. You can check with the continuity with the meter just as you did with a separate ohmmeter. You have the proper positions here before the meter connecting it to the circuit. Like the ohmmeter, if the hand moves to 0 with the lead connected to the wire component with the continuity, a hand does move with the infinity. There is no continuity. There is an open circuit with the excess of the resistance. If the hand stops between the infinity mark and 0, there is a readable resistance in the circuit. The resistance might not be normal, might be normal if there is load type of the component of the circuit. If there is no load component of the circuit, there could be a bad connection somewhere. The continuity test will generally to show this type of defect. The continuity test of the one circuit will switch to indicate that the resistance switch contact could be. Yeah, I had a taco. I'm alright. Alright, the continuity test will generally show the type of the defect. The continuity test of one circuit will show that it indicates your resistance switch contacts will going to be dirty. This is one example of the malfunction causing resistance of the circuit. As you multimeter check for the continuity, you will learn how to help with locating loose connection, broken wire, dirty contacts over the malfunctions. When you're finishing using the ohmmeter, turn the range selector for the any position of the resistant position, preventing discharge of the meter battery with the case of the test leads accidental touching each other. Alright, you can use the multimeter measuring the DC voltage. As you can see, the multimeter can be a valuable test instrument with the wheeled vehicle. Repair. You can use the locate shorts and broken with the circuit to measure the DC voltage as well. If the other, remember, when you use the multimeter as an ohmmeter, make sure the circuit has to be tested has no voltage in it. And also turn the voltage off, otherwise the meter can be damaged beyond repair. Alright, learning event 4. Describe construction using a simplified test equipment and internal combustion engine. The simplified test equipment of the internal combustion engine, variable testing measurement of the vehicle engine, as well as the other types of electrical mechanical equipment to protect the transit case complete. All exercises easily transported field site with a general measurement and diagnostic connector assembly test. Capabilities. Simplified test equipment and internal combustion engine had 3 major capabilities. General measurement capabilities. The general measurement. The simplified test equipment and internal combustion engine can be used with the same voltage, current, resistant pressure for the speed measurement without specific vehicle equipment information, making general the measurement of the vehicle test meter receives power from the power cable to W5, the DCA cable to W1. The test data received with the various test probes cable to the transducer. Special test. Simple test equipment and internal combustion engine equipment can be used to test specific vehicles, Army inventory, recognized vehicles, and the identification number entered for the VTM or vehicle test meter. The simplified test engine equipment and internal combustion engine is automatically used the vehicle information stored with the memory together with the test data to give the result. In performing special test of the vehicle test meter, the receive the power from the battery through the power cable to W5, the DCA table with the cable to W1. Test data may be received with the various test probe cables and transducers. And then you have your diagnostic connector assembly test. The vehicle equipment will be tested with the permanent with the DCA with the vehicle test meter with the receive of the pole power with the test data of the DCA with the cable to W1. The wire of the DCA connects with the test point with the vehicle equipment. The power source with additional transducers can be used at the same time with the test points of the DCA. Features. Provide summary measure of the equipment conditions, measure of the broad range of the test method quickly, accurately, simply set up and operate, interpreted, portable, built-in protection against common operator errors, operates at 12 and 24 volt power supply. VTM is your vehicle test meter, is test electrical mechanical components reading of the either pass or fail digital display. Vehicle test meter interface of the vehicle, the equipment being tested with a transducer kit with by the DCA, and from the vehicle test meter with the drum of the vehicle equipment, the battery for the alternate power source, flip cards attached in front of the vehicle test meter provide a quick but limited reference for the operator with the flip cards to test and the messages, numbers and messages. Some procedures, test limits are provided for some of the vehicles. Your transducer kit is tray inside with the transit case contains the transducer fitting of the connector for the transducer kit is stored in a model tray within top of the transit kit. The transducer kit numbers are shown with the illustration reference only do not appear on the way on the tray. Many of the fittings do not have the part number markings on them referred to the transducer kit item number and name. Alright, Trony sells the transducer kit, item 10, hose and fitting assembly, 27 current probe, and then 20 transducer kit, 12, 30, 3/4 inch reducer, and 29 transducer kit, item 13, half-inch item reducer, and then figure 30 transducer kit, 3/8 of an inch reducer 2. Figure 31 transducer kit, item 15, 1/4 inch pipe plug. Transducer inducer kit, 16, 1/8 of an inch pipe plug. Transducer kit and item pressure transducer, item 18, 1/4 inch male connector. Transducer kit, item 19, pipe reduction coupler. Transducer kit, item 20, adapter 2. Transducer kit, item 21, snubber. Transducer indicator item pressure reduced transducer. Figure 39 transducer kit item number 23 3.5 inch straight T. Figure 40 transducer item 24 quarter inch straight T fitting. Transducer kit 25 eighth of an inch straight T. Transducer kit item 26 quarter inch straight elbow. Transducer kit item 27 eighth of an inch straight elbow. Alright, figure 44, transducer item kit 28, inverted plate, flare T, transducer kit item number 29, adapter connector, transducer kit item number 30, ignition adapter, transducer kit item number 31, tachometer drive adapter, transducer kit item 32, fuel line adapter, transducer kit item number 33, air chuck, transducer kit item number 34, pulse tachometer, transducer kit item number 35, flexible hose assembly, transducer kit 53, 36 long hex pipe nipple. Alright, continuing, reading now. Your cable assemblies. Cable assemblies include the power assembly testing referred to as the number of the quick identification, each for the cable, the name of the described to you. For example, the DCA cable, the connectors or cable identified with the number preferred with a P, either P or an E, and a P1, E2, or so forth. Cables assembly with a simplified testing equipment of the internal combustion engine are the D1, W1, DCA cable, W2 test probe, and W3 ignition adapter cable, the W4 transducer cable 2. W5 power cable. Figure 53 shows the diagnostic connector assembly cable to W1. Use the vehicle test meter provide except for the test point sensors connected with the vehicle equipment of the DCA. When the DCA measurement is being performed, both power and measurement information received in W1. Alright, your test probe cable to W2. The general and special measurement of the measuring voltage, frequency, resistance. Continue with the also further peaks and compression unbalanced test. The W2 is divided into two color leads, red E1 and black E2. The test clips E1 and E2 are W2 attached to the points of the equipment test lead. Figure 55 ignition adapter cable W3. Using measurement well angle with the points of the RPM power test divided into the two color leads of the red E1 and black E2. Alright, figure 56 transducer cable to W4. Use the connection with the vehicle test meter with the transducer pulse, tachometer, current probe, ignition adapter cable, and transducer cable that can be joined under the connection with the adapter transducer cable, item number 29. Alright, figure 57, the power cable to WS. The vehicle test meter with the cable to W1 is not being tested. Cable to W5 is divided in two leads with color-coded leads, red 1, E1, black E2, battery cables, clips. E1 and E2 attached to the vehicle equipment and battery with a 9 to 32 volt and 4A regulated power supply. Never connect VTM to a battery charger unless connected to a battery damage or damaged vehicle test meter may result. Or your transit case. The simplified testing equipment in internal combustion house portable protective transit case contains all necessary accessories. A relief valve at the front of the case allows operator to release pressure vacuum caused by change of the climate during transit. Principle of operations section to draw the principle of operation simple testing equipment of vehicle test measurement cables accessory black diagram shows the power control display. Vehicle test measurement show the control from the display, going to display, the clock going to control, the test button going to control, the test switch going to control, and your vehicle test meter measurement electronic going to vehicle equipment and back to the measurement signals, back to the VTM, and the power going from the vehicle equipment to measurement, and then the alternate power source is also available. Power supply vehicle test measure on vehicle equipment, the battery alternate power source measurement information sent with the vehicle test meter is compared with the values stored in the memory. The setting of the test select which text tells the VTM which measure the produced do. Pressure releasing test button with the vehicle test meter performs the measurement procedure. Vehicle test meter displays show the result of the being used, volts, RPMs, PSI, so forth, and pass or failed message. Figure 59 shows resistance. A vehicle test meter. Selecting test meter switch for required test numbers tells the vehicle test meter to make the resistor measurement of the test button is pressed and release. Vehicle test meter supply with the electrical current vehicle equipment under test. Vehicle voltage across the equipment and the test is measured. Resistance calculated in vehicle test meter. Vehicle test meter displays resistance in ohms or kilo ohms. Or your AC voltage measurement, the figure 60 AC volts setting the test Test switch is required to test the number of VTM to do the AC voltage measurement. The test button is release AC voltage values vehicle equipment under the test VTM. VTM range displays average values single and volts. Pressure measurement. Figure 61 setting the test switch with the required test number to tell the VTM to make a pressure measurement. Test buttons pressure relief vehicle TM supplied with the constant voltage pressure transducer. The pressure transducer returns the voltage portion of the pressure being measured. Voltage drop of the transducer measured with the converted in pressure of the VTM. VTM displayed with the PSI gauge in inches mercury or inches of water. Current measurement. Setting test switches required with the test number of the vehicle test meter, the current of the measurement of the test button, switch press release, vehicle test meter with the constant voltage of the current probe. The current probe returns voltage proportion of the current being measured. Variant voltage developed in the current probe is measured, converted to the current by voltage test meter. Voltage test meter displayed with the current in amps. RPM measurement. Check with the test switches in the required test number to tell the VTM to measure the RPM in the measurement. The test button has been pressed and released. On CI engine, the VTM measure the test time needles and engine revolution. At SI engine, the VTM measure the time between cylinder firing. VTM internal clock time reference converts the measurement of the RPM of the VTM display with the engine speed and RPMs. Alright, operator control and indicators. Figure 64 shows connectors. Your DCA power connector J1, you have the VTM either for this vehicle diagnostic connector DCA cable W1, DC power supply, power cable W5, DC power supply is usually the vehicle batteries. Transducer cable connectors J2 T transducer kit and J3 transducer kit. Using the transducer cable, the W4 vehicle test meter using the transducer kit measurements power signals routed through these connectors. Both connectors may be used to require two measures made at the same time. Volts and ohm connector J4 use the connect test probe W2 VTM voltage resistance. And this shows the read output flip cards. Or readout display. Display the different type of the readout during the testing of the maximum 4 characters. Type of the readouts are staff to keep the operators informed what is happening in such apply to fail their tests or so forth. Numerical measurement result of the measurement of PSI, RPM, volts, or so forth are not displayed. And an error informs the operator with the error the wrong test method is entered or transducer is not connected or vehicle test meter is faulty and so forth. Flip cards are general information to aid in testing. Alright, figure 66 shows your switches. Test button. The test button, test push button switches the two functions. Press release, cause these test measurements to begin. Press and hold initiates offset. Test select switches. The two 10 position switches. Use select test to perform VTM when test button is pressed and release. Push on pull switch. Use the control power of the VTM from a power source which contains 4 amp circuits breaker to protect the voltage test meter internal circuitry. Alright, error message. Error messages include VTM that need additional corrected information before being tested and continue additional procedures. Error message displayed with an E followed by 3 numbers, for example. And then show the error message displayed. And status message keeps an operator informed what's happening. Status message or means are following in there. And then prompt messages. Prompt message meaning the operator must do the same after operation action. Testing will continue. Prompt message their meanings are as follows. And then it gives a practice exercise, a blank page, and then an answer sheet. And you can catch the rest of lesson 3 in its own book, and it's called Simplified Testing Equipment, Internal Combustion Engine, and the Wheeled Vehicle Aipd series. And this has been a reading of your Wheeled Vehicle Electrical System Part 1 Subcourse number OD1002.